Now I'm bringing up this old way of long division because you guys know how to do this. You would set up the 79,537 inside this division house thing. It has a special name, but I can't remember it. And you're dividing it by 20. You put the 20 on the outside. And so because it has two digits, you would look at 79 and you would ask yourself, well, how many times can I take 20 out of 79? Or you would say, what times 20 will get me really close to 79? And hopefully you would say 3, you would get 60, and subtract, you get 19. Then you would bring down the 5, and then you would ask yourself, 20 times what will give me 195? Well, 20 doesn't go into 195 exactly. So what you would do is you would pick a number that's close to it. It goes into 180, which is 9. And that would be 180, and I would subtract that. I would get 5 and 1, then bring down the 3. Okay, this process of going, this times what will give me that? And then you put it up here, and then you multiply it, and then subtract it. That's the same thing we're going to be doing with polynomials. Now, if I were to finish this, let's see, it'd be 140. This would be a 7 right here. I subtract, I would get 13. I'd bring down the 7. And then I would say 6, and that would be 120. Subtract would be 17. Then you would put remainder 17. But then you learned about fractions, and then instead of putting remainder 17, you would put 17 over 20. So the answer is 3,976 and 17/20. Well, you can start doing decimals. And yeah, you do remember fractions because you guys remember doing things like this, I would hope. Like if you had 39 over 4, that's an improper fraction. And so what you would do is you would say 39 divided by 4, you would get 9, 36, subtract, you'd be left over with 3. And so you would say your answer is 9 3/4. So yes, you have been doing it. When you change an improper fraction to a mixed number, you're writing the remainder as a fraction. That's the same thing that we're going to be doing with polynomials today. So let's get started because there's a lot of steps involved in this. The only stinky part is all the writing. There's a lot of writing, but I believe that most of you guys will get this pretty quickly. So you put the top polynomial inside your, I think it's called a divisor. I can't remember that, which makes sense, like a visor. I don't know. Anyways, you put it inside, and then this is what you do. First, you make sure that all your terms are there. It needs to go in descending order. Like if it says x to the third, then this next one should be x squared, the next one should be x, and then we have our constant, the one with no variable. It always needs to have all the terms, and we'll look at one that doesn't have all the terms. So what you do is you look at just the first numbers. Don't concern yourself with the other numbers when you're trying to figure out what goes up here. What times x would give me 6x to the third power? So I'd put a 6x squared right here, and I put it above the x squared. And the reason why I do that is so I know which one I'm supposed to bring down next. And so now what you're supposed to do is take this and multiply it to that so you can subtract it. You guys remember the long division stuff? But when you multiply to it, you're going to have to distribute. So that's a different thing about with polynomials. So I go 6x squared times the x, and I get 6x to the third, which is right because these have to be the same every time you do this. If they're not the same, then you're doing it wrong. Then we go 6x squared times -2, and that will give you -12x squared. This one doesn't have to be the same as that one. He's not the first one. The first ones always have to be the same. The next thing you do is you would subtract it. But remember, you're subtracting the whole thing. In fact, I want to write that in red because everybody always forgets this. Always, always, always subtract the whole thing. Okay, so what I like to do is I like to distribute the negatives, so I just have to add. Makes less mistakes with negatives. This one should always cancel out if you do it right. And then the next one is going to be, what is that, a 7x squared negative. Then you bring down the next number, which would be 16x. Now, I'm looking at this x and looking at this right here and saying what times this x will give me negative 7x squared. Now, just like what I said with the previous one, if you can't figure that out, or you're not thinking about it, you can say negative 7x squared and divide it by x to figure out what you have to multiply to it. You subtract the exponent, so you get negative 7x. And so that's what our next number is going to be, negative 7x. Once you get that, then you multiply it times that. You get to distribute, and you get your new polynomial that you're going to subtract. So I get negative 7x squared. And then negative 7x times negative 2x will be positive 14x. Then you subtract the whole thing. And this is when you would normally distribute your negative. So you're really adding. These two added together gives me 0, which they should be. And then you get 2x, and you bring down the minus 4, which is the last one. Now this one actually works out to be really nice and even. 2 times this would give me 2x minus 4. And then because they're exactly the same, I know I'm going to get a 0. And whenever you get a remainder of 0, that's when you know that whatever you're dividing is a factor of what you're dividing. So our answer is 6x squared minus 7x plus 2. Because this times this would give you that. Alright, so that's the end of that one. One that divides into it perfectly. Since it divides into it perfectly, we've got a remainder of 0. We know that this right here is a factor of this. And if that's a factor of this, then we also know what one of the solutions are. If this was a function, we know what one of the x-intercepts are. One of the x-intercepts would be a positive 2, because that one is a factor. Alright, so let's look at one that's missing some terms. So this one's missing some terms. What do you do when you're missing terms? When you're missing terms, you fill in the missing terms with a 0. So x to the third plus 0x squared plus 0x, and then have your minus 1. So these guys I had to add in, because I had to have a placeholder for those. They always have to be in descending order. And so then we have the x minus 1 on the outside, and then we can get down with it. Okay, I'm going to go a little faster this time. I had to say that again for the video. Alright, Alright, so I go x times what will give me x to the third. That one was, it's just x squared. X squared times x gives me x to the third. So now I have to distribute it to the x minus 1, which will give me x to the third. Negative 1 times x squared will be negative 1x squared. Don't forget, you must subtract the whole thing. Distribute the negative, because we don't want to mess up our negatives. And my result is just 1x squared. These ones cancel each other out. My next term is just a 0x. What times the x will give me 1x squared? Yeah, just 1x. And so I go plus 1x. And now I go x times this. I must distribute. I get x squared minus x. And then I'm going to subtract the whole thing. So I distribute the negative, and I get that's gone, and then I'm left with an x, and then minus 1 is the last one I have to bring down. And look, it goes into it nice and pretty. Sweet. So this is just plus 1. I go x minus 1 and subtract the whole thing to get 0. So this one is a factor of this, because I got a remainder of 0. So, but this is my answer, x squared plus x plus 1. Okay, the next one we're going to do has a remainder. And so I'm going to show you guys what that looks like.